Okay, so if we have two or more objects are connected or in contact, then we can apply the Newton's law to all of the objects and so for the answer, right? Okay, now let's say here we have a so-called the Atwood machine. Atwood machine is a machine in which we have the pulley, we have the pulley here, and we have two objects, M1 and M2. They are hung or attached to two ends of the rope. Uh, at this moment, we ignore the mass of the rope here. We ignore the friction, and also we ignore the mass of the pulley. Okay, three things: the mass of the pulley, the mass of the rope, and the friction are ignored. Now let's try to solve problem. We have the assumption here that M1 moves up and M2 moves down. Right? So first of all, what we need is to draw the diagram for the M1 and M2 objects. Okay, so this is again the Atwood machine. We have the tension force for the both object, the gravitational force for the two objects, and then how we draw the free body diagram. So in this case, for M1, you have M1G T. For M2, we have M2G and T. So each object has only two forces, right? The diagram is okay. If you draw that, try to draw the T with the same length for the two vectors here. M2G is a little bit longer than M1G because M2 moves down, right? Okay, and you see here, normally we have two dimensions, right? But in this case, the objects move vertically. Then we need only one axis. But we have two different positive direction, right? For M1, because M1 moves up, right? So you see here, for M1, the opposite direction is upwards, and for M2, the positive direction is downwards, right? Pay attention for that. Upwards, downwards. So this is the direction of the real motion, right? You have to consider the direction of the motion, right? Okay, pay attention for that. You need to consider the direction of the motions. Okay, now equations. Equation. For the M1, you have to write down a little bit because we need that. Sorry. M1. Oh no. My computer plates. M1. I didn't like this. M1. I want to write something, but it. No. Wait for me a little bit. The computer play with my pen. Yeah, thank you, Phương Thành. Okay, now I get okay, from the free body diagram, I get M1G plus T equal to M1A1, right? In this case, I write A1 for the mass M1, M2G plus T equal to M2A2. You see? Actually, A1 goes up this way, A2 goes down this way, right? So they have the same magnitude, A1 equal to A2. Why? Because the string here is unstretched, unstretchable. Unstretchable. It means the length of the rope is constant. Right? So the length doesn't change. So we have this one. Then we convert the vector equation to the algebraic equation by using the direction of the motion as the axis. Okay, then you get this. For the object M1, you have T minus T is upward minus M1G equal to M1AY. Now A. Option number 2, M2G minus T equal to M2Y, AY. Then you solve for AY. So we have to solve for AY, right? This is my hint. You can see you have T here with the plus sign, we have T here with the minus sign, so you can add the two equations here, side by side, right? From the left side, you have minus M1G plus M2G. From the other side, you have M1 plus M2AY, right? Then you can easily get AY. AY is minus M1. I simplify the expression a little bit. Okay. So we get the answer for the acceleration. If it's clear to you, then give me the number 7. Okay, thank you. I want to say something about this. When you look at the expression here, you have the denominator, right? The denominator here. You can see that in the denominator, you have only the plus side. If in your answer, there are some minus side, then it will be wrong, definitely. Okay? In the denominator. In the numerator here, then it can be negative, it can be positive, it depends on the problem, right? But in the denominator here is always the sum of the masses. Later you can have something different, but all of the quantities here in the denominator will be mass, or will have the dimension of m. My computer, please. Sorry. It doesn't help me anymore. Okay, let's start begin. Okay, you can see here, right? In the denominator, now we have the masses, right? The masses. The dimension of m or mass, or the unit of kilogram in SI.
Dạ thầy ơi, em không thấy cái màn hình này.
Chưa thấy cái màn hình ha, vậy thì bị lỗi rồi. Cái máy tay hôm nay nó chạy hơi trục trặc chút xíu. Ok, thấy chưa?
Dạ rồi thầy.
Nó bị lỗi ở đây, thầy bấm cái nút cái là nó đi luôn. Rồi. Ok.